MCP is great until you connect multiple MCP servers with hundreds of tools and your context window just explodes. Anthropic published a blog post explaining exactly these problems and how to fix them in detail. In this video, we'll go through the proposed architecture by Anthropic, look at the good parts, the bad, and the ugly, and see how these capabilities can be used in our own agent workflows. So let's dive in. When MCP was launched, it gave a universal protocol. Developers implement MCP once and it unlocks an entire ecosystem of integrations. But there are two big issues here. Let's say you have your LLM, your agent, and the MCP server. You load your LLM context window with system prompt. You also call your MCP server to fetch and load all the tool details, such as the tool name, description, and arguments. Then we add the user's question and send our first request to the LLM. The LLM responds back with a tool call. Let's say we got a massive tool call result back, a Google Doc file output. We send this to the LLM and the LLM responds back by saying that we should put the file data as input and call another tool too. This comes back as another tool call that we then send to the MCP server and we get the result back. Now there are some big issues here. If you have multiple MCP servers and the number of tools are suddenly too many, you end up consuming most of your context with these 100 plus unwanted tools without making even a single LLM call. Massive tool result consumes additional token and you quickly fill up your context window. And third, if the second tool call depends on the output of the first one, the whole output of tool 1 is put in context again for input to our tool number 2. And this also does a double entry of the context window. Now to solve this, there are two major changes required. Treat tools as files. These code files internally calls the MCP servers as APIs. The agent can use a search tool to find all the relevant MCP server files. This later on becomes the basis for a term called agent skills, which is a topic for another video. The second thing is to create sandboxes to allow our agent to write code using these tools in mind and execute the code in a sandbox safe environment. Cloudflare calls it code mode. Now the agent can write code using these two MCP servers and we can execute that in a single shot. So in this use case, if you want to call tool 1 and that gets you the output of a file transcript from Google Drive and use that text output as input to another Salesforce tool 2, you can do that and execute the code straight away in a sandbox. So we can see that our new format uses the context more efficiently by loading tools on demands and filtering data before it reaches the model, executing complex logic in a single step without intermediate output polluting the context window. One more thing to note here is that the model can write code that can do parallel tool calls, which in the previous use case would have been extremely slow with agents converting 10 documents at once. But there are downsides too. This whole setup needs more number of agent round trips for things like searching and executing code. While the cost is lower due to fewer tokens, for simple direct use cases, this might turn out to be way more slower in terms of latency. And finally, this setup forces us to create and use core sandboxes. That adds up another layer for security and infrastructure to maintain. Because of this, interesting use cases are possible now. The Anthropic blog beautifully describes the top 5 use cases that we can do with this. One is progressive disclosure. Anthropic suggests that a search tool can be added to the agent to find the relevant definitions. So instead of the whole code file, the tool can return back with the name, description, and tool definition. And instead of you loading all the tools at once, you can then filter, search, and then add the tools when and as necessary. We also have something called context-efficient tool results, where, for example, you want to manipulate a 10,000 row big Excel and filter based on a condition. Instead of the whole Excel loading into the context, here the agent can write code to filter and peek into the Excel file and print only the top 5 rows for the LLM. You also have code-based control flow. Loops, conditions, and error handling can be done with familiar code patterns. For example, if you need a deployment notification on Slack, the agent can write code to wait and check for loop rather than you doing a multi-turn agent call to get the job done. We also have higher privacy preserving operations. When agents use code execution with MCP, all the intermediate results and sensitive data stay in the code execution environment by default. This way, the agent only sees what you explicitly log or return. And therefore, if you want, you can either not provide the data, mask the data, or only give non-sensitive data in response. You also have state persistence and skills. Now that the LLM can write to a file system that gives them freedom to create their own to-do list and save progress state, it can do long, complex running tasks. And we have discussed what skills are, where all of this code can be reused and be defined as a particular skill that the agent can use in future as well. In conclusion, MCP provides a foundation protocol for agents to connect to systems. However, once too many servers are connected, tool definitions and results can consume excessive tokens, reducing agent efficiency overall. Agent skills and providing access to code sandboxes can be useful in a lot of scenarios to speed up the task, but they have the issues of their own, and it can be neglected in a lot of use cases as well. That's it for this video. I'll see you in the next one.